The objective is to express 2023 in a sum of consecutive integers. For examples, it can be the sum of two integers 1011 and 1012, or the sum of seven consecutive integers from 286 to 292, or even the sum of up to 4046 integers from negative 2022 to positive 2023. Question: how many such expressions are there? Let's look at the example of seven integers. Assume their sum is s. S can be expressed as the sum of the numbers in decreasing order. Then we sum up the two equalities term by term. Left-hand side is 2s. The sum of the two first terms is 578. The sum of the second terms is also 578, and so on. Divide by 2. We have s equals the sum of seven numbers. They are all the same, 289. Therefore, s equals 7 times 289, which is 2023. This example tells us two key points. First, the number of terms, the number of consecutive integers is related to the factors of 2023. In this case, 7 is a factor of 2023. Secondly, we can calculate the sum of a sequence of consecutive integers by sum up the first term and the last term and multiply the number of terms divided by 2. This formula is also applicable to every arithmetic sequence. Let 2023 be the sum of integers from m to n. Then 2023 equals the first number plus the last number, that is m plus n, multiplied by the number of terms n minus m plus 1 divided by 2. Therefore, m plus n times n minus m plus 1 equals 4046. Where m can be negative, m plus n must be positive, and the number of terms n minus m plus 1 also positive. Therefore, both m plus n and n minus m plus 1 are positive factors of 4046. Let's list all of the factors of 4046. This is related to prime factorization of 4046, which is 2 times 7 times 17 squared. The factors of 4046 are different choices of these prime factors. There are a total of 12 combinations. These are the factors from 1 to 7 all the way to 4046. Total of 12 of them. The number of terms n minus m plus 1 must be one of the factors. There are a total of 12 cases. The first case, there's only one term. N minus m plus 1 equals 1. Only one term. This term must be 2023. Second case, if there are two terms, then m plus n equals 2023. Only two numbers, and one of them is 1011, the other is 1012. The next case, there are 7 terms. N minus m plus 1 equals 7, and m plus n equals 578. the multiplication of these two numbers is 2023. So this is actually a system of equations in M and N. We solve for them. M is 286, N equals 292. We see this example before. We can solve all these equations. The last one would be the number of term equals 4046. So starting from negative 2022 to all the way to positive 2023. Let's look at all the solutions. The first one, there's only one term, of course, that is 2023. If there are two terms, we've seen this before, 1011 plus 1012. And next one, 7 terms. And it can also be 14 terms starting from 138 to 151. And the next one, there are 17 terms from 111 to 127. And the next one, we have 34 terms from 43 to 76. So far, we have 6 solutions. They are all positive integers. And the next one have some negative integers in it. Starting from negative 22 to positive 76. You see, the last number, 76, is the same with the previous one. They are actually related. So if we sum up from negative 42 to positive 42, everything's cancelled. So essentially, we start from 43, sum up all the way to 76. This is exactly the previous case. Let's look at the next one. From negative 110 to positive 127. This is related to the solution of 17 terms. You see, the last number is 127. From negative 110 to positive 110, everything's cancelled. And it can be 289 terms, 578 terms, 2023 terms, starting from negative 1010 to positive 1012. Essentially, there's only two positive terms, the last of the two. And the last one, there are 4046 terms. Only the last term is essential. Everything else cancelled. Thank you for watching.